Okay, so next is carbanion, carbon anion. So what are carbanion? Again same study we have. What are carbanion? Preparation of carbanion, stability, types and stability, etc., etc. Okay, and tell me what are carbanion? Tell me what is carbocation? The organic compound in which carbon carry positive charge. Positive charge having how many valence electron? Having 6 valence electron after sharing is a carbocation. Then carbanion is similar, the organic compound in which carbon carry negative charge. Carbon carry negative charge and having how many electron? 6 plus 2, 8 electron in valency shell after sharing. Therefore, the difference is in carbocation positive charge, carbanion negative charge. Carbocation has 6 valence electron, carbanion has 8 electron in valency shell after sharing. Okay, so therefore the organic compound in which carbon carry negative charge and having 8 electrons in valence shell called carbanion. So what is the preparation of carbanion? So how do you prepare carbanion? So usually carbanions can be prepared from organic compound having acidic hydrogen. So can you tell me which organic compounds having acidic hydrogen? Let us take aldehyde ketones. We have studied in ketoenol tautomerism. Okay, aldehydes and ketones having at least one alpha hydrogen. They are acidic or not? So there are 3 alpha hydrogen. 3 alpha hydrogens are acidic nature because this is electron withdrawing group. So therefore, in presence of any base OH minus, this OH minus abstract H plus, so that what you get? CH2 negative charge, C double bond OH will be same. That is a carbanion. Right? Organic compound which are having acidic hydrogen. Even like alkyne, for example CH3, C triple bond CH, which is reacts with sodium metal. This is also we have studied. Tell me here which is a acidic hydrogen? The hydrogen present on sp carbon, that is a CH. So this hydrogen acidic, therefore which is reacts with sodium metal. Okay, then tell me CH3, C triple bond C, it becomes negative. Of course there will be a sodium, Na plus comes and hydrogen liberated. Therefore this is also anion, carbanion, carbon containing negative charge. So therefore usually the organic compounds which contain acidic hydrogen can form carbon containing anion. Okay, so it is a preparation of carbanion. Next is the most important is its structure. So what is the structure of carbanion? Then types. Let us see the structure of carbanion. Simplest carbanion is CH3 minus. Remember this negative charge indicate a pair of electron, 2 electrons. Okay, can you tell me CH3 there are carbon containing 3 bonds with hydrogen and there is a negative charge pair of electron. So what is the hybridization? Then what is the bond angle and what is the lone pair geometry? Tell me. So hybridization. So what is the formula to calculate the number of hybrid orbital? The number of hybrid orbital equal to sigma plus lone pair. So there are 3 sigma bond plus lone pair is 1. So it is 4. It means hybridization is sp3 and lone pair is 1. Do you know bond angle? Lone pair is 1. Then geometry, sp3 1 lone pair, it is always pyramidal, like ammonia. sp3 1 lone pair, its bond angle also approximately equal to ammonia 107. It changes, it depends on again hydrogen. See, if there is a hydrogen, it comes nearly 107. On place of hydrogen, if there are other groups, it changes. Okay, but for this it's nearly 107, like ammonia. So therefore, then here central atom is carbon, it has 2 hydrogen, 3 hydrogen, and there is a 1 lone pair, and the geometry will be like this. It is pyramidal geometry. Next is types of carbanions. Types of carbanion. So what are the types of carbanion? 1 CH3 minus, B CH3 CH2 minus, C CH3 CH negative CH3, and D it is a methyl carbanion. This is primary carbanion, 2 degree carbanion, and 3 degree carbanion. So there are 4 types of carbanion: methyl, primary, secondary, tertiary carbanions. Okay, then stability. So what is the stability of carbanion? The whole topic depends on only stability, and moreover that only important. Even in carbocation also the majority question comes on stability only. So similarly, stability of carbanion. Can you tell me, carbanions are unstable because of what? Negative charge. So as we discussed, usually carbon having no charge is more stable compared with carbon having charge. Like it is a neutral carbon, which is more stable compared to C plus, which is also more stable compared to C minus. So obviously neutral species are more stable compared to charged one. Because of charge they are unstable. Now here also we are studying the stability of carbanion. Carbanion is unstable. Carbanion is unstable due to presence of negative charge. Therefore, when the carbanion becomes stable, so when you are able to reduce the charge, if you are able to reduce the charge of the negative charge of the carbanion, it becomes more stable. Now, what is the meaning of reducing? It is not mean that negative become neutral. No. The charge density decreases. Charge density is decreases. It means negative charge density slowly decreases so that it becomes stable. Therefore, when the negative charge density decreases, when there is electron withdrawing groups, it means electron withdrawing groups present on negative charge, then what happens? The stability of carbanion is increases. Therefore, so what is the stability of carbanion? So stability of carbanion directly proportional to electron withdrawing group. It is inversely proportional to electron releasing groups. The whole topic depends on this only. So stability of carbanion directly proportional to electron withdrawing group. So what are electron withdrawing group? Already we have studied. That is minus I group, minus M group, electron withdrawing group. There are only two groups, minus I, minus M. Then what are the electron releasing groups plus I, plus M and hyperconjugation also. But here condition, when the hyperconjugation possible only 3 molecule, 1 carbocation, 2 alkene, 3 free radical, because 3 are having sp2 hybridization, sp2 carbon. It means for hyperconjugation, so already we have written hyperconjugation is possible in case of carbocation, in case of alkene and in case of carbon free radical, and that too they must have at least one alpha hydrogen. If they have at least one alpha hydrogen, they can exhibit hyperconjugation. If they exhibit hyperconjugation also electron releasing effect, it releases electron. Okay, so therefore now what are the factors affecting on stability of carbanion? Okay, the same factor which is we have studied for carbocation. Can you tell me, for carbocation which factor we have studied? 1 inductive effect, 2 resonance, 3 mesomeric effect, 4 hyperconjugation. So therefore the same factor comes here except last one. And tell me factors affecting on stability of carbanion. First factor, inductive effect. Inductive effect, 2 resonance, 3 mesomeric effect, 4. Fourth one is, there we have studied hyperconjugation. Here hyperconjugation do not come. Why? Is it carbene can undergo hyperconjugation? No. So hyperconjugation possible only in case of carbocation, alkene and free radical. Why it is possible in these cases, we will study next topic, that only electronic effects. There will study individually separately. But here remember, instead of hyperconjugation, here another effect is percentage of S character over R, electronegativity of carbon. Their hyperconjugation, here it comes percentage of S character. So therefore these are the 4 factors which affect the stability of carbanion. So let us study one by one. First one is inductive effect. Again it is same as like carbocation, but it comes opposite. Tell me, first one, inductive effect. So what is the relation between stability of carbanion and inductive effect? In inductive effect there are 2 inductive effects, plus I, minus I. Tell me, which effect stabilize the carbanion? Minus I. It means the stability of carbanion, directly proportional to minus I group, inversely proportional to plus I group. Okay, so therefore stability of carbanion directly proportional to minus I group. So what are the minus I group? How to remember minus I plus I groups? Remember, minus I groups are the groups or atom which are having more electronegative element. Okay, irrespective its nature. If any element having more electronegativity of any group having more electronegative central atom, which is a minus I group. Then what are the plus I groups? Remember, alkyl groups, all alkyl groups, methyl, ethyl, propyl, N-butyl, whatever it is, all alkyl groups are plus I groups. Therefore here only important is example, how to identify the stability. So for example, let us see, it is a simple example, methyl carbanion primary carbanion, secondary carbanion, tertiary carbanion. So among these, what is the order of stability? Tell me. So order of stability. To identify the order of stability, we need to identify first which groups are there. Okay, tell me. Here it is a 1, 2, 3. These are which groups? They are plus I group. And moreover, carbon carrying negative charge, it is negative charge, negative charge. There are 3 plus I group. Here is how many plus I? 2 plus I group. Here is, okay, 2 plus I group. Here is only 1 plus I group. Then here is, there are 3 hydrogen. We know that hydrogens are neither plus I nor minus I groups. So therefore, tell me now, what is the order of stability? Methyl, right? CH3 minus, because plus I group decreases the stability of carbanion. The stability of carbanion inversely proportional to plus I group. As the number of plus I group increases, stability decreases. Therefore, there is no plus I group, methyl. Next is, that is methyl is, take A. The next is B, C, then D. One more example. It is 1, 2, 3, 4. Tell me the, so which is the order of stability? Which is most stable? 4 is a most stable because there are 2 minus I groups, right? 2 minus I group, because nitrogen is a most electronic element. Here is 2 plus I groups. Here is 1 minus I group. Here is 1 plus I group. Therefore, which is most stable? Fourth one is most stable. The next is second one is most stable. Then there is 1 plus I group. First one is most stable. Then third one. So this is the order of stability of carbanion. It means as the minus I group increases, stability increases. As the plus I group increases, stability decreases. Okay. Suppose one more. Let us take chloro methyl carbanion, fluoro methyl, bromo methyl, iodomethyl. So which is most stable? See, all are minus I groups, chloro, fluoro, bromo, all are minus I group. But we also know that minus I effect is directly proportional to electronegativity. As electronegativity of an element increases, minus I effect is increases. Therefore, now among this, which one has highest minus I effect? Fluoro has highest. The next is chloro, then bromo. Therefore, which is most stable? So it is 1, 2, 3, then 4. Which is most stable? That is 2 is most stable. The next is 1 is most stable, then 3, then 4. Right? So this stability of carbanion based on minus I and plus I effect. Next, second factor is resonance effect. Resonance effect. Tell me. So what is the resonance effect? So here we study resonance effect, not only carbocation, we will study carbocation, we study in carbanion, even free radical also. So wherever resonance comes, remember resonance always stabilize the molecule, irrespective nature. Irrespective nature, resonance is always stabilize the molecule. That means, so as the number of resonance structures increases, the stability of molecule is increases. Now let us see here carbanion. So what is the relation between stability of carbanion and resonance? It is directly proportional. Therefore, stability of carbanion directly proportional to number of resonance structure, RS. As the number of resonance structures increases, the stability of carbanion is increases. Okay, the next. Now wherever resonance comes, we study two molecules very frequently. Which two molecule? One allylic and benzylic. So we have studied same molecule in carbocation, we will study in carbanion, even we are going to study same in free radical also. Wherever resonance comes, in textbook also mentioned nearly on 15 to 20 times these structures are given in the textbook. So therefore you can understand importance of that. So therefore let us see example allylic carbanion. So this allylic carbanion undergo resonance, negative charge shifted here, this pi bond shifted here, so that okay. Now I want what is the hybridization of all three carbons in allylic carbanion. Okay, anyhow we understand this is sp2 sp2 because double bond. Wherever double bond comes sp2, but wherever negative charge comes sp3. But here is what? It is sp2 only, not sp3. So here all the carbons having sp2 hybridization, even though including this negative charge. Why? Due to resonance effect. See, there is a one important statement. See, negative charge in case of carbanion, if the negative charge present adjacent to the conjugation, right, or negative charge lone pairs are in conjugation with pi bond, then this negative charge should not be involved in hybridization when it is involved in resonance. This negative charge involved resonance, that's what it should not involve in hybridization. If this comes in hybridization, that should not go in resonance. So therefore this negative charge should not be taken in hybridization. So we have studied in aromatic compound this concept clearly. Therefore all are sp2. Next, benzylic carbanion. So in benzylic carbanion also same negative charge. Tell me, this negative charge form the bond here, at the same time this pi bond shifted on adjacent carbon, that is on ortho position. Ortho position gets negative charge and this is CH2. Now CH2 negative charge was there, this negative charge formed the bond. Now there is no charge on carbon. Next, now this negative charge formed the bond in between these two carbon, this pi bond shifted on para position. You will get the negative charge on para position. Next, this negative charge formed the bond here, this pi bond shifted on ortho position, then negative charge appears on ortho position. Next, this negative charge ortho position shift the bond, then negative charge is shifted on CH2. Okay, this is 1, it is 2, it is 3, it is 4. Then what about last one? It is equals to first. Therefore, so allylic can form only 2 RS. Then what about benzylic? It form total 4 resonance structures. Therefore, when you see the stability of allylic and benzylic, which is more stable? benzylic carbanion is more stable compared to allylic carbanion. Okay. Then let us take example. Tell me, so which is more stable? First one, right? So why first one is more stable? Because there are 6 resonance structures are possible. Here 6 are possible. Here is 4. Here is 2. As the number of RS increases, stability increases. One more example. Let us take triphenyl carbanion, diphenyl carbanion and phenyl methyl carbanion. So diphenyl methyl, triphenyl methyl, diphenyl methyl and phenyl methyl, nothing but benzyl. Which is more stable? So triphenyl, then diphenyl, then phenyl methyl carbanion, because number of RS is increases. Okay. Next, one more example. Let us take benzyl carbanion and at para position there is a methyl group, comma, in para position there is a NO2 group, comma, in para position there is a methoxy group. All are benzyl carbanions. It is 1, 2, 3, 4. Tell me, what is the order of stability of these carbanion? Which is more stable? Say you need to see that what is the difference between all these. So benzyl is common, there is a methyl group here, methyl group, okay, nitro group, methoxy group. Methyl group is a which group? Plus I group. Methyl is a plus I group and it is a minus I as well as minus M. Remember, when NO2 is present on benzene ring or conjugation, it acts as a minus M also. Minus I will be there, along with minus I, minus M also be a possible for this NO2 when there is NO2 present on benzene ring. Next, OCS3, it is a minus I as well as plus M, but for OCS3 already we have studied plus M dominate minus I. Okay, so therefore now tell me, we know that electron withdrawing group increases the stability of carbanion. Which is more stable? Third is more stable, right? Because there is a NO2 electron withdrawing. Next, electron releasing, and no releasing, no withdrawing. Therefore, first one is more stable. There is no releasing, no withdrawing. Next, among second and fourth, second also releasing and fourth also releasing, where the electron releasing is more? Plus M effect. Methoxy releasing more means less stable, releasing less, more stable. Therefore, second is more stable than fourth. This is the order of stability. Okay. Okay, it is about resonance effect. And see, suppose one more. If there are number of electron withdrawing increases, like it is a benzyl carbanion having 1 NO2, benzyl carbanion having 2 NO2 ortho and para, and benzyl carbanion having 3 NO2 ortho comma para and ortho. Tell me which is most stable? Obviously fourth one, because as the number of electron withdrawing group increases, stability of carbanion is increases. Similarly, as the number of electron releasing group increases, stability decreases. That is common. So this is the second effect, resonance effect. And third one is mesomeric effect. Mesomeric effect. Right. In mesomeric effect, again there are two effects, plus M, minus M. So which is a plus M effect? Electron releasing effect. Minus M is electron withdrawing. Now tell me, stability of carbanion. Stability of carbanion is directly proportional to minus M effect and inversely proportional to plus M effect. Okay. So stability of carbanion directly proportional to minus M effect. So which are the minus M groups and how to identify minus M groups? In last class we have studied the groups which are having multiple bond with carbon, multiple bond with more electronegative element like this. Right, the groups which are having carbon multiple bond with more electronegative element, or even nitrogen multiple bond with more electronegative element like this. So this kind of group where you get aldehydes, ketone, carboxylic acid, ester, acid halide, acid amide, acid anhydride, many more. Here NO2, even carbon multiple bond, even cyanide also. So these can exhibit minus M effect. Plus M, the groups are atoms which are having one or more lone pair electrons, like OH, 2 lone pair, like NH2, 1 lone pair, like SH, 2 lone pair, and its derivatives, OH derivative OR, NH derivative NHR, and SR, many more. Those are plus I groups, plus M groups. Okay, now here we want stability directly proportional to minus M effect. Okay, for example, let us take same example here. No, this is because of plus M only. Okay, anyhow, one example. So it is a benzyl carbocation having NO2, benzyl carbanion having methyl or methoxy. Okay, tell me, it is 1, 2, 3. So what is the order of stability? Which is most stable? So here you need to understand NO2 is a which group? Minus I as well as minus M. Here this OCS3 minus I as well as plus M, but plus M dominates minus I. Next here no minus I, no plus I. So therefore which is most stable? 1 is more stable than 3, then 2. Okay, one more. Let us take allylic carbanion NO2, allylic carbanion having methyl and just allylic carbanion. It is A, B, C. Tell me, what is the order of stability? Decreasing order. Which is most stable? A is most stable because NO2. Next is C is stable. Then next comes B, because B unstable because of plus psi effect. Okay, so like that mesomeric effect also stabilize and destabilize the carbanion. Next, last one is electronegativity or percentage of S character. So this is we have studied in hybridization topic. So what is the relation between percentage of S character and electronegativity? Yes, as the percentage of S character increases, electronegativity increases. So we have studied this, like in sp3, sp2, sp. Right. In sp3, sp2, sp, what is the percentage of S character? Tell me the percentage of S character here. 25, 33.33, 50%. It means sp carbon has highest electronegativity because highest percentage of S character. Okay. So therefore, and we also know that percentage of S character is directly proportional to electronegativity of carbon. It means, for example, take ethane carbon, ethene and ethine. All three are carbon only. Okay, carbon, carbon, carbon. Whether all the three carbon having same electronegativity? No. That means electronegativity of any element also depends on hybridization. The same concept you have studied in structure periodicity in property. Okay, that means element is carbon only. Okay, its electronegativity not constant. It depends on hybridization. Therefore, here percentage of S character more. It has highest electronegativity, then double bond, then triple bond. Okay, and now tell me, we are studying the stability of carbanion. Let us take carbanion with alkane, alkene, alkyne. So which carbanion is most stable? Alkyne carbanion. Why? Because this carbon has more electronegativity. Of course, this also more electronegativity. Due to electronegativity, more electronegativity, this carbon takes electrons. It has electron withdrawing nature. So due to electron withdrawing nature, it becomes more stable. Therefore, sp, sp2, sp3 order of stability. For example, CH triple bond C, it is CH2. CH2 double bond C, CH, CH2 and CH3, CH2, CH2. Can you tell me? So what is the order of stability? You see it is sp carbon, sp2 carbon, this is sp3 carbon, right? So which has more electron withdrawing nature? sp carbon, then sp2, then sp. And moreover, because of resonance possible, no? Here possible, here possible. So therefore, that is also one reason. And this is, therefore, as the electronegativity of carbon is increases, the stability of carbanion is increases. Next, some specially stable carbanions. Do you remember the same concept we have studied in carbocation? Some specially stable carbocation. There are two carbocations are most stable. One aromatic, second one CPM, cyclopropyl methyl. Cyclopropyl methyl. Tropylium is aromatic. Okay, so aromatic carbocation is most stable. Along with aromatic, even CPM also most stable. Why? We have studied with reason. So here also, here CPM does not come, only aromatic carbanion. So aromatic carbanions are most stable because of aromaticity, because of aromatic nature. So therefore, one aromatic carbanions. So all aromatic carbanions are most stable. Okay, for example, stable, unstable. Stable or unstable? Stable, because 6 pi electron stable, that is aromatic. Next, tell me, stable or unstable? Unstable. Why it is unstable? There is a 1 and 2, no, means 4 pi electron. 4 pi electron, it comes anti-aromatic, unstable. So unstable means does not exist. This molecule, this ion does not exist. So we have studied anti-aromatic compounds does not exist. Highly unstable. Next, this is why 6 pi electron, it is aromatic, stable. Okay, next, eight pi electron, unstable, that is anti-aromatic, unstable. Okay, then yesterday someone asked one doubt in that class. This compound can be make it stable, no? How? For example, there is a lone pair. So when this lone pair or free electron does not enter into the ring, it becomes 1 pi electron. Yes or no? If 2 electron does not enter into the conjugation, it becomes 2 pi electron. If it is a 2 pi electron, it is more stable, no? Is it possible? That is also not possible. Why? Suppose it is all right, this 2 pi electron, does not enter 2 electron does not enter into the conjugation, it become 2 pi electron, it become stable. But we need to see the planarity for aromaticity. So if these 2 electron does not enter into the conjugation, it becomes how many? Yeah, it becomes what hybridization? It becomes sp3 hybridization. If sp3 hybridization, it becomes non-planar. If it is a non-planar, again no aromaticity, right? Even in that case, it is aromaticity is not possible. Okay, so therefore, but there is a conjugation, you cannot stop. You don't have any barrier to stop. If there is a conjugation, it involves conjugation. If not, molecule become non-planar. Okay, so anyhow, and that is not possible. If it is even does not exist, also not aromatic. So these are the some important aromatic carbanion. Now let us see overall stability of carbanion. Order of stability of carbanion. Order of stability of carbanion. Tell me, in among the carbanion, which carbanions are most stable? Of course, aromatic. Aromatic carbanions are most stable. Then, after aromatic carbanion, which carbanion is most stable? Triphenyl methyl carbanion. Yes or no? Next is diphenyl methyl carbanion. Next is phenyl methyl, means benzyl carbanion. Then tell me, after benzyl carbanion, allylic carbanion, 2RS. Next, after allylic, primary. Before primary, methyl. Before methyl, methyl is sp3. Before methyl, can I take this? sp carbon, no. Carbanion with sp carbon most stable. The next is carbanion with that is sp2 carbon. Next comes this or not. Before this you can take now methyl carbanion. Methyl, then primary carbanion. Next is secondary carbanion. Next is tertiary carbanion. Next, that's it, no? So this is the order of stability of different carbanions. Okay.